Okay, today we need to review exponential functions. We talked a little bit about them last week. Exponential functions are ones where we have a to the x, and this a is a number. All right? It could be, for example, 3 to the x. And we said that the common feature of all of these is that all exponential functions, if it is the parent function, if it's the granddaddy function, all exponential functions are going to go through 1 and they're going to take off exponentially. It'd be the same thing for 4 to the x or 5 to the x. Or, if this is 3 to the x, would e to the x look much different? Because remember that e is just a number, right? Like pi is. So if I were to graph, now remember what this is 2.7 something. So it's a little bit smaller than this, but it's still going to go through 1. It's just maybe not going to grow quite as fast. That would be e to the x.
Isn't that faster?
Yeah, I should have drawn it on the other side. Sorry about that. It would not grow quite as fast. It'd be over here. All right? Now, what would happen if I wanted to graph, I'll get another color, how about orange? What if I wanted to graph f of x equals 3 to the x minus 2 without a graphing calculator? I have people whispering in the room that I would go to the right 2. What would go to the right 2? This,
where it hits 1.
that little magical point right there would go to the right 2. So this would come over here, and it would go through there, and there's 3 to the x minus 2. So all of those transformations still work with exponential functions. All right? Now, what I want to get to before, so that we're not rushed, because this is a part of what we're doing tonight, is taking a look at some regression equations. All right? So let's do that next. Let's use the data in table 1.8 to estimate the United States population. I think it's United States population. Yes, United States population. U.S. population in the year 2000. Okay. So if you look in this is in your book, by the way, and it's on page 24. So if you look on page 24, there's a data table. All right, and we're not going to recopy the data table in our notes. We're going to go from here straight to the TI-84, and I'll put a couple of pictures up. Now this is a good review of something that we did last week. If you remember, we select Stat, Edit, okay, and we start entering our data. Only this time our first year is 1880. And our next year is 1890, 1900. And I'm actually going to pause the video here while I enter the data, to save you some time. All right, we're done entering data now, and from here we're going to do just the same thing that we did last week. We're going to go back to our Stat menu, and we're going to select Calc. Now, this is a section on exponentials, so we want to select an exponential regression equation. Okay, so you hit enter, and there we have it. So we have used the graphing calculator to get a regression equation, and the nice thing is they actually give us the base form of this. All right. So our base form is f of x equals a times b to the x. So then we just fill in. I've got this 1.598. Erase my line here so I can see what I've got. 1.599 actually times 10 to the negative 10th times 1.014 to the x. There is my regression equation. Okay. Now, if I wanted to look at this as a scatter plot, you remember how to do that, right? I would go back to my graphing calculator. I would go to y equals, go up to my plot, make sure it's turned on. All right. And then I would go to zoom stat. Which is 9. Yeah, I could have saved some time. Use 9. There is our scatter plot of the data. Now, does it look like an exponential?
Yeah.
It does look like an exponential. All right. So I'll paste that in here. There's our scatter plot. Now, what do I want to do, though, to answer the question? I mean, do we remember how to graph my regression equation? Oops. You remember how to graph this on here? You just go back into y equals and type it in, all right? But what would I do? Either way, I'm going to need to enter this function. Okay? Either way, I'm going to need to enter the function. So let's go back to the graphing calculator and enter my function, which was, help me out here, 1 point, I'm going to put it in parentheses actually, 1.599 times 10 caret negative 10
It's 10 to the, it's 10 power.
times, and then what is my base? 1 point what? 014 caret x. Okay, and then we can hit graph. And that one didn't superimpose real well. But at this, I'm not going to take a bunch of time to figure out what my goof was. I'm sure it was just the way I entered the numbers. What would I do, though, to come back and answer my question? We'll figure out that goof with the superimposing later. But what would I do to answer this question, to estimate the population in 2000? If I have the function in there, can I just go to the table?
Yeah.
Right? I mean, once you've got the function in, then all you really need to do is, check your table set. We're looking at the year 2000, so maybe I would start at 1990, go up by tens, and you could do ask as well. You could do it that way. Then go to your table, and it looks like it's going to be 190.44. All right?
Yeah, I struggle with those.
So that's why we took a few minutes to go over that. And I will put a screenshot of that in my notes. Just a second. So to answer our question, we went to the table. All right? All right, so that's an idea of regression equations. Let's go over some kind of algebra type things. What if they ask you to rewrite the expression to have the indicated base? You'll like these because this is just being able to do a little bit of basic algebra. Let's say that they gave you 25 to the 3x. And they said to write it with a base of 5. Now, this is pretty easy. How can I write 25 as a power of 5? 5 squared. So I can make this into 5 squared, but the whole thing is to the 3x power. Now we have to use our rules of exponents, right? Power to a power, we multiply 5 to the 6x. All right, so you're going to have a few problems like that. Let's do another one that involves maybe a negative exponent because people just tend to struggle with those more often. 1/27th to the 4x, and we want to write it with a base of 3. So how can I write 1/27th as a base power? The base is 3. 3 to the what? 3 to the negative 3. Okay, this is the same thing as 3 to the negative third. All right? And that whole mess is to the 4x power. So then we would do power to a power, and I would get 3 to the negative 12x power. What's that? No, because we wanted to write it with a base of 3. So we've done what we were asked to do. Now, you're also going to be asked to do some transformations like graph without the TI-84. And I'm trying to remember here. Yeah, I think they're actually like matching problems, you know. So they're going to give you some graphs. Like this, maybe. A, B, C. and then they're going to give you, you know, some problems. We'll call this problem 1, 2, 3, and they'll say f of x is 3 to the x, f of x is 3 to the negative x, f of x is negative 3 to the x. I don't know. I didn't give you a fourth graph, but I'll throw this up as a possibility. Negative 3 to the negative x. And then you have to match them up. All right? So, obviously, don't we know which one number 1 is?
Yeah.
Number 1 is what?
1A.
B. Okay, it's this one. Because this is the parent function.
Oh, I drew A as B.
Now, I can use my head and reason out which one number 2 is. Think about it. Think about what this means. Doesn't this mean 1 over 3 to the x? So doesn't this mean, aren't all of these still going to be positive, right? But they're going to be getting progressively smaller.
And it's 3 over x because you can't have a negative x, right?
Well, now I'm just trying to help you understand why it's the graph that I'm going to select. The answer is C for that one. Because, let's think about it. What is 1/3 to the second power? It's 1/9. What is 1/3 to the 20th power? It's 1 over something really big, isn't it? Which means it's going to be getting really close to 0. So this one, all right, is number 2.
Oh, because it goes to 0, but it
Right.
goes down.
Okay? And then you have to be thinking for number 3, for this last one here, all right, you have to be thinking, well, it's going to be getting really negative and really large, right? So we don't want to say number 4 because number 4 is going to be getting negative and small. Number 3 is going to be getting negative and large, okay? So that kind of, you know, we learned some rules about when the negative's on the inside, the negative on the outside. Sometimes those get confusing with exponentials. I think it's better to think through it the way that I just talked you through it. Now, a couple formulas here. First, interest compounded annually. And we actually talked about these last year. Y equals the principal times a to the x. That's for interest compounded annually. And then for interest compounded continuously, it would be y equals p times e to the RT. Okay? Now, let's look at an example where we're going to be doing this. And you're going to have several in homework like this. How much time is needed for an investment to double in value if interest is earned at 7.25%, and we're going to say it's compounded, we'll abbreviate, annually. Okay, 7.25% compounded annually. Well, as soon as you see that it's compounded annually, that tells you which formula to use. I would write it down. Y equals P times a to the x. That's the first thing I would do. Now, let's think about what we're wanting here. Did they give me the principal? They didn't give me the principal. So that means I need to just keep the principal in here. But they did say, how long is it going to take for the principal to double in value? All right. Now remember, this y right here is actually telling you the final value. So what they're saying is, when is this going to be 2 times the p? So I'm going to put a 2p over here. Because that's what it's asking. When is that principal going to double? Okay. Now, what do I do with this interest rate? Well, what we're going to do is we're going to add that to 1, and this is going to become 1.0725 to the x. And the reason that's the case, the best way that I can explain that is to think of sales tax. When you go to Walmart, let's come over here to Rivendell for a minute. You go to Walmart, you buy something for 20 bucks. 7% sales tax. How do you find out your total amount? Well, you could do 0.07 times 20, right? And then add it to 20. But couldn't you also just multiply this by 1.07? If you just multiply 1.07 times 20, wouldn't that give you your total bill? Right? It would. The idea is your total bill is going to be the original amount, which is the 1, plus the 7% sales tax. Well, interest earns the same way. It gets added on to what you already had. Okay? So that's why we put whatever this interest rate is, we just add it onto 1, like that. Okay? Now, how I need to figure out how to finish this problem. Well, the next thing I can do is I can do a little bit of algebra and divide both sides by p. And now I have this. 2 equals 1.0725x. Now you might be thinking, well, what do I do now? Well, this is where we are going to graph this, and I'm going to graph this, and I'm going to look for an intersection on the graphing calculator. This is the quickest way that I know to do this problem, is to graph y equals 2, graph 1.0725 to the x, and look for the point of intersection. I think it's by far the quickest way to do this problem. I've tried doing it other ways. Now remember to turn your plot off. We don't need that plot on anymore. And clear this junk out. I'm going to enter 1.0725 caret x, and I'm going to enter y equals 2. Okay? And then we're going to graph it, okay? And it's probably, we might want to try zoom fit. There's one for zoom fit, and just see if it will work it out for us.
Oh, mine did it. Just trace it over.
Yeah, you're just, no, that's where you do second calculate, intersect. Mine's taking a while to figure it out. But you're going to go to second, calculate. What you're going to get, since my calculator is hung up here, what you're going to get is you're going to get, after you find where the two places meet, here's y equals 2, you're going to do second, calc, and then intersect. Okay, and that's going to tell you how many years it takes for it to double.
Wait, so
And we're going to stop there.